Hi everybody, this is a questions for Pundit's Tutoring. Today we have a function and it's a calculus problem. The question basically goes like f of x equals sine square, 2x squared, and then our goal is to find the derivative of the actual function. So if you look at this, you would notice that this is a fairly complex function, right? At least it has 3 levels. It has an exponents components to this, and it has a trigonometry function attached to it, and then within the trig function it has a quadratic equation, a function in there. So when they ask you to find the derivative of f of x, what you're really trying to do is find f prime of x. So this is a fairly typical question for the use of chain rule, right? So when the use of chain rule is basically saying that you take a derivative of a function first, and then whatever within the function you take it again, right? So but you do it individually. So you only work on one function at a time. So in this case we have 3 levels. So the first step we need to deal with is the exponent part, right? So we remember, the basic derivative part of if you have a function of x of n, right? The general equation is when you do f prime of x, right? The exponents come down in front of the function times x and minus 1, right? So in this case, we're treating the whole thing as of x, right? So we're only dealing with the square. So what do? We move the 2 in front, and we leave the whole thing behind. Basically, we don't touch it, and we put 2x squared. And in this exponents, it was 2 minus 1, right? So it's basically 1. So we just leave it as is. Now, the next step is chain rule. So, chain rule means we're dealing with the second part of the function. We only deal with one function at a time. When you're dealing with that function, the rest of the function, you leave it untouched, right? So in this case, what you do is dealing with sine of whatever function is set. And we know that in, just you would have that table. So if your f of x is, or in this case we'll change it, we'll call g of x. Right, your g of x is sine whatever in there, x, right? So g prime of x equals cosine x. And that just given to you. I'm not going to do the proof of that. But, so the derivative of sine function equals to cosine. So the next step, since we've dealt with the exponent part of this, we're going to deal with the trigonometry part of this. So we're going to deal with that, and any chain rule you do on multiplications, right? The second part, since we dealt with that, we don't deal with it anymore. We'll only deal with the sine function. And the derivative of sine is cosine. So write cosine. Now remember, we're only dealing with one function at a time. There's 3 layers. There's the exponents, there's a trigonometry, and there's a quadratic part of this. So we're dealing with the trigonometry part. So we leave this part, the quadratic part, untouched. So you just write it. Now the final part is the simple part of this, right? So we all know, using the same equation, you break the exponents down, so 2. So the last part of this, I'm going to write it here, right? I'm just going to do a little bit of a separate. So 2 times 2 is 4, x, because it's 2 minus 1 with the exponent, right? And if your teacher does not require you to simplify the solution, this is good enough. If your teacher requires you to simplify the solution, then there's multiple ways to simplify this, right? Because if you look at this, this is actually a trigonometry identity, or you can combine a 2 and a 4. But other than that, most calculus class teacher would just be okay with you leave it like that, or just simplify the constant part. So you can write 8x, and then sine 2x squared, or cosine 2x squared. If your teacher is being really fancy, they can take this part and change that into some sort of trig identity, so that becomes sine 2 of that, right? So you can say sine 4x squared, and then you have 4x there. But I think this is really optional. This is like optional. You don't have to do that. I mean, this is kind of fancy. I mean, I don't think you need to do that part very much, but this is good enough. And thank you.